All right, everybody. So we're talking about problem decomposition. We just read through Georg Polya's four-step problem-solving process. Let's talk about it a bit. So step one, understanding the problem. So we talk about this in terms of like programming problems. Give me some examples of things that we might need to do to understand the problem.
Understanding like what the end goal is trying to be.
Yeah. So like I'd even simplify that down to like what's the output? But the output is kind of ultimately a subset of end goal. What else do we need to understand?
The data types we're working with?
Yeah. What else helps us understand the problem?
We can also ask ourselves, is there enough information to enable us to find a solution?
Like, is this solvable? Do I have enough? What would I need? Is the thing that I would need to make this solvable? Do I have that? Could I get it? How hard would it be to get? Those are all questions you might ask yourself in here. What else?
Can you like restate it in your own words?
Yeah, restatement. That is huge. Anything else? It's pretty good. So in programming, we spend a lot of time working with transformations. So if this is your app or your function or your file, your whatever, it's taking in inputs and generating outputs. Like at pretty much every level of software, something like this is happening. We can't have something that generates outputs with no inputs. That's in the systems diagramming world, we call that immaculate conception. We also can't have something that something goes into it, nothing ever comes out. In systems design, we call that a black hole. So everything that happens inside of this box is turning these into these. And you could look at that as, it's almost like a law of conservation kind of thing, where if this is the fundamental thing that's happening, well then inside here, maybe we also have smaller versions of that. That end up generating that.
This is just calculus principles, correct?
Correct. But even if you didn't make it through 6th grade math, just conceptually, inputs and outputs, man. So a big part of what we're doing in this first step, what is this box? What are we getting in? What is coming out? Ergo, what transformation needs to occur? Do we have sufficient inputs to generate these outputs? Questions about that? Cool. So we are going to look at the problem that I did yesterday in that live coding session. I don't think many of you were in that. That's probably the right move for you, but that actually makes this more effective. So let me pull up the problem statement for that. All right, so this is the problem that I was given yesterday for that live coding thing. Let me split this up just a little bit, but this is how it was given to me. Okay, cool. So if you got given this problem, we don't have to solve the problem. It took me an hour and a half to solve the problem yesterday. We're doing step one. What kinds of step one tasks would you do for this? Let's spend a few minutes on this. Like actually work through it. Just step one stuff. What kinds of things do you need to clarify? What kinds of things do you need to restate? What does the box look like? Go, 4 minutes. Not coming up with solutions. Just trying to understand the question. What's being asked? All right. So I'm gonna call on some people. I want to see what sort of things you teased out of this. Lucky Lou, give me one thing that you pulled out of these prompts.
It wants you to create like a set of data where you have like the title, the ride type, wait time, current line, and number of seats.
Okay, so title, thank you, Lou. Type, wait time. And as far as the other things, that's kind of interesting. So that's what I thought also. It's on the video, you can watch it. But the more that I looked at this, you get the line length and all of those things, but really all that's in the output is title type and wait time. So they're not super explicit about it. We want to calculate the current wait time. We get those things in, calculating wait time, and then we're sorting these rides from shortest to longest. There's actually a couple of these different things, but it doesn't say anything about including that information in there, just that we're using it in the calculation. So if we're doing this in an interview or whatever, that's a real good thing to clarify is, all right, do I also include this stuff you gave me in the output? It's a little ambiguous from the thing, but I think they just want the wait time, title and type. Excellent. Let's hear from Cho. Anything else you were able to tease out of this?
Basically all the inputs are like they have the inputs of arrays of strings.
Mm-hmm.
So it gives you the ride title, the type of ride, and the ride length in minutes, and the number of seats, as well as the number of people in line.
Absolutely. And the kind of weird thing that caught me off guard when I was doing this is that, yeah, they're arrays of strings, and all of that is in one string. So we have all these little pieces of data that somehow we got to pull out of there. Excellent. Good takeaway.
Yeah, I had a quick question about that. That struck me as really odd, but is there like a real life scenario where you would actually store data like that?
Absolutely.
CSV file.
Time.
Okay.
Yep. So that could have come in from a CSV file like that. That could have just been like, oh, we don't actually have an app that puts these things together. Mark down at HQ just types this in a text message and we pull it out of that. It could be any number of things. We did optical character recognition and I don't know, somebody wrote it on paper and we just pull it out that way. But yeah, you totally get data in busted ass formats like that.
Okay, cool.
I'm going to open it up. Other things that you guys saw for Polya Step 1.
I saw that it wants to organize like multiple ways at the end, where it's like first it wanted to go by shortest to longest, and then alphabetical by name, and then by type, and then by just listing all of them out together.
Yeah, that was kind of a curious thing too. So this sort right here, not the same as the sort that came before it. So I did the exact same stupid thing. That sort and this sort are two totally different things. So that's going to be two different outputs that we need.
You could almost go through and eliminate a pretty good amount of information after you read through it once or twice. So like, for instance, the second sort is by title.
Yes.
Like you're not going to have rides with the same, or I mean, you might, right? But, and then like what you were talking about earlier with all the extra variables that are in there, because they're not explicitly stated, you can pare the whole thing down. And then if you need to make it more robust later on, you can go back and adjust your inputs.
Outstanding, Jack. So yeah, we want that data included in this, but we wouldn't expect rides to have the same title but different types. That wouldn't make any sense. So it would really just be sorting by title. That's the thing we could clarify. Somebody's asking us to do this. Is like, wait, there's no rides with the same title of more than one type, right? All right, cool. I can get rid of that. And Jack brings up another good point. We also really don't need any of this. This is like, this doesn't give us any data for solving the problem. And so we can shorten how much we're looking at, which might help focus a little bit.
So is the main objective of this problem statement, like the main thing they want us to do is calculate the wait times first, and then after you calculate all the wait times, then we'll get into the whole sorting?
That was my read on it. And if somebody's asking you to do this, that would be a very good problem restatement.
For that, calculate the wait time.
Mhm.
If that is the first thing that we need to solve. I think there are some questions of if we have enough information. First of all, does line length equal number of people in line? Because that's two different phrasings that I would want clarification on.
Beautiful. But this is one of the things that I struggled with yesterday when I was working through this is domain language. So you use line length, like, is it line length or line count? And if you can figure out words to use for those that you can use consistently throughout the thing, you will have a much easier time actually solving the problem. And I'm sorry, did you have a more idea?
Oh, yeah, I mean, it was starting there with that, and then based off that information, for calculating the wait time based on, actually, I don't even remember what I was gonna say, so never mind.
So for calculating this wait time, I was assuming current number of people in line and line length were the same thing, and these are just matching up.
I remembered what I actually did want to say that based on that. So like once that has been clarified, still don't quite have the data we would need because we have it all in that one string. So you kind of touched on it, but recognizing, okay, I don't have the data I need integers.
Yes. So sounds like what we're pulling out of this is that we need to transform the data so it's not just all trapped in that string. And then we need to do a calculation, and then we need to do a sort. Cool. We need to do two sorts, actually.
We could also sort it, do another sort early on if we want to turn that the strings into hashes in order to identify like the different variables for each one.
Totally. So that's, well, let's take a look at how I did it yesterday. I still have my notes from it. All right, what did I actually do? Weird. I figured out what all the different parts of those strings were so that I could put them in a hash. I broke down that transform into, all right, I have a string, I need to make it an array, and I need to make that an object or hash. Like in JavaScript, objects are actually closer to Ruby hashes than Ruby objects. So we're doing this transformation. We calculate out the wait time, and then we do these two sorts. So that's starting to get into the second step a little bit. That was like devising a strategy. And in our case, like us understanding the problem naturally sort of led to a strategy around this. Ask me some questions about this.
Yeah, just a little bit confused with how it was stated. It says that once it's sorted by length, and then immediately once it's alphabetically sorted by title right after that.
Yes.
Wouldn't that just like defeat the purpose of sorting it by shortest to longest first?
So the way that I read this, and like also I think the wording on this is terrible. spoiler alert, this is Comcast's junior dev like screener tech thing. And they don't send you to technical interview question writing school before you do any of this shit. So yeah, there's some ambiguity in here. So sort the rides by ride type and then sort by wait time. So I read that as, all right, so we get all of the things of this type and then this type and then this type. Within those, we're sorting by wait time. And then within those, if two things have the same wait time, then we go by title.
Oh, okay. If two have the same, yeah.
Exactly. So it's three.
Because it just says, oh wait. Did it specify shortest? Then for rides of the same type and wait time. Okay, yeah, I missed that part.
Cool. Other questions about step one?
My thinking with the two different kinds of sorting would be that if you're offering it to like the consumers or the visitors of the amusement park, you're trying to give them the option of one, if you sort by title, trying to find the ride that they're looking for. But then if they're just there to get through the rides as fast as possible, then you want to have the other sort.
Definitely. And that's where, like, so in the absence of any other guidance, this color text up here actually comes in a little handy because they're talking about why you need the feature. So that might help give us some guidance actually. And if something's ambiguous and we can't get it clarified, well, we can go back to what the purpose of this was in the first place. Cool. So step two on this would be, all right, can we think of a few different ways to solve this? And so in our case, in understanding the problem, we came up with this solution, or strategy rather. It's not the only one we could have done. Anybody think of other ways we could have approached this problem?
I think you could calculate wait times first and add it as into the string and then sort, or and then transform and sort.
Absolutely. We don't have to do the transform first. We could do this within the string. We could even like try doing the sort first and then do the calculation and then do the transformation. We're always going to need to do some version of all three of these things, but the order isn't fixed on that. Okay, with that piece of information, what else are we doing in step two?
I mean, you would need to convert the numbers that are within the string to the proper data type of integer.
Yeah, so that's this transformation here, but I don't have to do the transformation first. I need to do it for the calculation, though. That's a pretty good point.
You could go ahead and like you have the right types because they give you that in the strings, so you can do an elimination of one single sort off the beginning, and then go ahead and like either transform the data and then calculate, or calculate it into the strings and then transform that into the correct data type we want.
Cool. So what kind of criteria might we use to do one approach versus another approach? How do we know whether one's better than another?
I have a question. What you mean by the approaches? Are we saying like either we can turn our string into an array of hashes, you know, and have everything else sorted like orderly for us, so it's easy to pull out the data, or we could just kind of like by parsing the string be like, okay, based on whatever the thing is after that first comma, let's sort that first, and that, okay.
Yeah, we could totally do that. Or since these things all start with the title, and title is one of the sorts that we're doing, we can just sort the strings in place. We could do all of those and then do like the transformation for each one and then do the calculation. works.
Is this asking for like three entirely separate arrays that are sorted?
This is that's a good question. What output type are they looking for? And so they don't specify. And so what I did was an array of hashes.
But three different arrays of hashes. One that is sorted by ride type, one that is sorted by estimated weight, and then one that is sorted by alphabetical.
I did this as two different sorts, but I agree that the wording isn't super clear. I did it as sort by ride type, and within ride type by estimated wait time, and then alphabetical order, and then sorting the list of rides by title. But yeah, you could totally say like, oh, it's three different ones. So we'd have to clarify. So we have a couple different ways we could go about solving this. And I think the transform, calculate, sort one is the most promising, because if we have two different ways we need to sort it, or potentially three, that's where the most variation is happening. And so if we can push that out to the end, keep the stuff that's shared between them up front, keep the stuff that's different at the end, I think that's going to result in a cleaner solution. So the next thing that we do as part of step 2, in programming in particular, is what we call an input-output table. This is us trying to understand the black box. We go, all right, if these inputs are 1, cat, and true, we should get back blue and 17. So how do we go from this to this? And ordinarily, you'd represent that as an input-output table. So if I get this array of strings, does it generate this output? And then with this one, does it generate this output? And this is still like kind of in problem clarification land a little bit, because we're saying like, all right, I'll know this works if this turns into this, this turns into this, this turns into this, right? You can use that to help clarify. So with that, you've defined what the arrows in the box are and what the box is. The box is whatever transforms this into this.
You would do that for each of the component parts. So you would do an input output for the transformation, and then you do one for the calculation, and then one for the sort, or?
Ooh, so yeah. At a high level, we want to do that for this. As we're working on the problem, might be helpful to also do these for these smaller things that are happening inside of the box, because it's turtles all the way down, man. All of these also have inputs and outputs. So, spoiler alert, here's how I actually did it. That like input output table, it's kind of like automated tests. And so I wrote automated tests. This was part challenge. So my input output table for the big box was calculates a wait time and sorts by title. Can I turn that input into this output? So I pass that into the function. Does the input turn into the output? And then by type, same thing. And then I absolutely did the smaller boxes. Could I turn this string into this object? This string, that string into this one, except they're arrays now.
Is that thought process what Sam was suggesting, like what we should kind of think our way through whenever we're trying to determine tests?
Yes, absolutely. Calculating the wait time. And like actually writing good, useful automated tests is difficult. This thought process you should always be doing. What inputs turn into which outputs? How do I know that I'm done? And so like for this one, like I just pulled up a calculator and actually like did the thing. Like, all right, if I get 6 back, I know that this worked right. What would you see on the screen that would give you confidence that like you solved the problem correctly? That's what you're trying to figure out.
Is there any literature you would recommend for testing?
Yes, there's this book, Developer Testing by Alexander Tarlander, is probably the best read on testing that I've ever seen. Also, testing is fundamentally about prediction, and it's very difficult to know how to predict how software should work when you haven't written a lot of it. So I've never met a new cat who writes tests like worth shit. So
okay.
It's not a thing I would like lose a whole lot of sleep over right now.
Okay.
How early on are you like planning out your methods to use to like write the tests? Because I know you need to know what methods to write each test, but
sure. So not in advance at all. Like when I was doing this yesterday, like you take the problems as they come. And so this first one, I write this test and I go, all right, what would I need to get me one step closer to turning this into this? I go, all right, well, just getting it in a similar kind of format would be a pretty good step. So can I turn one of these into one of these? All right, give me a method for that.
okay.
But a lot of it isn't about envisioning one grand solution to the whole thing. It's chipping away. How can I make this problem one step easier? And you saw that in the Hashkabal review stuff too, where like a lot of you just had nested eaches on nested eaches on nested eaches. You make those little helper methods, everything just starts getting a little bit easier. Not looking at a huge problem, looking at a little problem.
But we should always approach the problem with like how we approached Hashkabal, right? Like we made those long like nested eaches and maps and whatnot, and then we decide to simplify it even with the helper. Or is it like, is that too like of a thinking of a safe side of approach of it? Or because like I'm wondering if it's like better to think about it like, I know if I do it through the nested each method, it will work, but there is a better solution to it. But like,
so that's a good question. In general, you want to get it working, then you want to make it right, and then you want to make it fast, in that order. So like if the eaches are like, all right, I got confidence with that, I know I can do that, that's absolutely where you should start. For me, I go, all right, I got a data transformation. Data transformation is a map. I'm just going to reach for a map. I might refactor it into something else down the road, but like I'm less likely to tie myself in a knot with a map than I am a for each. For each, I trip over myself every single time. So getting it working for you is probably going to look different at different stages of your career. But yes, that's the most important thing. Whatever you're confident that you can pull off. But before you move on and start solving a bunch of other problems, after you get that dopamine hit from like that little piece of it working, stop and clean it up. And that's what I did in my solution with this thing right here, where I had a hash of things that look up different ways to sort. I didn't write it that way. That's like clever as fuck programming. I can't think that way in real time. I wrote it with a bunch of like if else things or switch statements or something like that. And then once I got that working, I kept it working as I did my like clever expert programmer trick. Other questions about selecting solutions, the black box, being clear about our inputs and outputs?
Once you decide on a solution track, do you usually follow it through, or do you kind of tinker around with it until you're more comfortable?
It can totally be an iterative thing.
Okay.
You can start going down a road and go, this is not working the way that I thought it would. All right, back to step 2.
Yeah. Okay. Kind of enumerate through solutions.
Exactly. And sometimes that's the only way you're going to notice that like something's a bad idea. You start trying a little bit, you're like, oh, I didn't think about that. All right, cool, back to the drawing board. Totally part of the process. So when you're working through a problem, step 3, smaller, make it smaller. Can you find a way to make the problem one that you feel confident with while working to your gradual solution? Now let's talk about step 4. In step 4, that's our reflect step. This is the easiest one to screw up. You'll go like, yeah, well, I'll reflect when I'm dead. It's the most important one. So things specific to programming in step 4, this IO table you made or the tests you wrote, do they pass? Does it work? Does the input actually turn into the output? And so when you do coding challenges that are like reverse a string, all right, if I'm reversing a string, if I get cat, I should get back tack. If it's capital C cat, then it's lowercase c, lowercase a, or sorry, it's supposed to be T-A capital C, same character, or should it be capital T tack? So whatever, you do all these things, they get an empty string, should bring back an empty string. Single letter. So you figure out what your inputs and outputs are for that. And then when you write your cool string reversing function, actually work through it with your inputs and make sure they turn into your outputs. You will catch a mistake you made in your implementation about half the time when you do that. If you're doing for loops or something, did you get the greater than or less than sign going the right way? Is it less than, or is it less than or equal to? Did you are using an old variable instead of the new placeholder variable you had? It's super common to catch mistakes, and they're not a big deal if you catch them, and that's how you catch them. And the last thing as part of step 4 is take a look at your solution. Could it be more effective? How? What kind of trade-offs did you ultimately end up making? And there's your 4-step problem-solving process. It's generic, works for just about anything.
When you personally get to step 4, do you find that you typically roll straight into it, or at that point would you kind of maybe get up and walk the dog and then go back and take a look at it, depending on the timeline, of course?
Yeah, it depends on the complexity of the problem too. So this one, not that bad.
Sure.
So, but yeah, so the problem solving thing, that's your linear brain.
Right. That's what I was thinking back to.
All right. So I want to analyze this. Yeah, I want my rich brain for that. Yeah, I'd say that's fair.
Okay. Thank you.
And yeah, when I was doing this, that's when I pulled this thing out. I was like, I really don't like the other way that I solved that. That's going to get messy if there's other ways that we need to sort something down the road. So fuck it. I'll extract this out. That shouldn't be too bad. And there's other things that are like, all right, well, the way that I did this is like super flexible, but it's not like the most efficient way we could have done it. Most efficient way we could have done it is probably something more like this, where we're doing it in place with each string. But that makes it less flexible. So that was a trade-off that I made. When we see students struggle with code challenge stuff in particular, it's usually a matter of fucking up step one, not reading carefully enough. Because like when you read something, most of the time you don't read it, you scan it. There's specific things that you're looking for. And so you're like, okay, where's the important details? Where's the important details? Where's the important details? Ah, cool, here. And it's not some deficiency. That's like widely researched. Huge part of usability research is you need to design text to be scanned, not read. Programming, though, we need to read. We need to slow down. You need to read it forwards. You need to read it backwards. You got to go really slowly. And the people who have like the most confidence and like, yeah, I got that. She's the ones who fuck it up the most. I did a reading test at Galvanize for a long time. You've probably done it at some point, where it's like, read everything before doing anything. And it's all these complicated ass instructions. And then number 17 is like, ignore all of this and just do this, put your name on the paper and turn it in or whatever. And I'd have people like, I have a master's degree. How dare you imply I have a reading deficiency? 50% fail rate on that one every single time. Even people who were teachers and have given that assignment before. So when you get a code challenge, slow down. Understand the instructions first. All right, asking some questions about problem solving.
I have a general one kind of about, it's more of a macro thing. So like, for example, like I have completed this bachelor challenge and passed all the tests. But I do know that there are ways for me to make it more concise and make it better. Would you say at this point in time, it's more important to continue on and kind of maybe go back to it at a later time, or to polish it up now before I submit it? Because I understand like how fast this course goes, but at the same time, I also don't want to not instill good habits from the get-go, if you know what I'm saying.
No, fair enough. So a great question and a couple things. You don't turn it in. Like, we don't review it unless you specifically ask us to.
Okay.
And going back and redoing it, it's not a matter of like polishing your work. It's, do you want more practice with enumerables? Refactoring the stuff that you did to like use more specific enumerables, like that's a great use of your time. But that's why I would do it. If you're like, okay, I'm actually feeling pretty good about those. I really want to like bite in on this classes and object stuff. That's totally reasonable too. And if you end up halfway through mod 1 and go, oof, I am actually not as strong with enumerables as I thought I was. Maybe I'll take a look at that bachelor assignment. Maybe do it again from scratch. Maybe see if I can do it really fast now. That is a perfectly good source of exercises for you.
Okay, so there's many different avenues to calculate benchmarks. Thank you.
Got it. What else?
So would you say that the greater the complexity of the problem, the more of a benefit that you'll get out of really fleshing out step 1 and really step 2? As opposed to like kind of just jumping straight into, because I'm definitely a victim of like, oh no, I got this. Right. And then just start like answering as I start to see solutions.
Sure. Yeah, like definitely. And even with like the simple ones. So string reversal is not hard. That also, and these things tend to like go along with each other. There's also a ton of different ways to do it, and they have different implications. So some of them are very space efficient. Some of them are very memory efficient. Some of them are easy to like do live in front of somebody. Some of them like require a little bit more like brain cranking. And so like even with the simple ones, it makes sense to slow down and make sure you understand. One thing we didn't talk about, boundaries. All right. Well, how long a string could we be talking about here? 1, 20, 4 billion characters, like makes a difference. So, but yeah, like when you see something like this, it's pretty natural to want to like jump in and go, all right, cool. Well, I know how to, I just write a function real quick to do this. Like I would fight that urge.
Do you mean we didn't discuss boundaries in the context of like I guess that would be what, step 2 or 4 whenever we were like kind of doing the testing stuff? Step 1, okay.
Yeah, that's when you're figuring out your
input output table.
You're clarifying the problem, and then you're representing that as the input output table. So
okay, so sorry. No, so like, just add boundaries to like part of step 1. Okay, yeah. Thank you. Sorry.
No, you got it.
Do you have any some resources for more of these problems, like a list or something?
Yes, I do. It is beerboarding.js.
Beerboarding, okay.
Or sorry, beerboardingjs.com. So this was made by some former students of mine from way back in the day. All of them thriving developers now. And they came up with a ton of these things. And I think these are way more appropriate and accessible than like a lot of the Code Wars, Kata, CS problem kind of shit. These are a lot easier to like get started with, I think. And they give you like some constraints and stuff too.
Okay, thank you.
Oh, I know a lot of these people. Tyler Mustard. Cool. Other questions? Ahmed did this one. Cool. Hopefully that's helpful. Cheers. Good hunting.
Thanks.
Thank you.